Okay, example 1 here for algebra 4-1, dealing with proportional relationships. So Erica is driving at a constant rate, hence that, constant ratio, constant unit rate. She travels 120 miles in the span of 2 hours. What is the constant of proportionality? So that right there might be freaking out because constant of proportionality is a big word. We haven't talked about that in years. Constant of proportionality simply just means that unit rate. What is the unit rate in this situation? So if I'm traveling, or if Erica's traveling 120 miles in 2 hours, what makes more sense? Miles per hour or hours per mile? Normally, when we're doing that, we see miles over hours. So 120 on the top and 2 on the bottom would give us 60, and again, keep the labels. 60 what by itself is not a unit rate. You need labels to make it a unit rate. Just like if we go back to our examples, $5 by itself is not a unit rate. Once you make it $5 per 1 hour, that turns it into a unit rate with those labels. So 60 miles per hour is that constant unit rate or that constant of proportionality that they were asking for. Part B asks me to write an equation to relate the distance, d, that Erica will drive over the time, t, that she travels, assuming she continues at the same rate. And when they say at the same rate, they mean the rate above. In part A. So here, we're going to use that equation that we set up. So our notes tell us that the equation is usually y equals kx. But in this case, they want us to be using d and t instead of y and x. So you just need to figure out which one makes more sense. Is distance equal to something times time? Or is time equal to distance times something? So I'm going to use that unit rate of 60 miles per hour to make my equation. So distance, that d comes first, distance is equal to your rate, which I'm filling in as the 60, and t is going to be my variable. Just like it would be y equals 60x. But instead, they asked me specifically to use those variables d and t, so I needed to do that. So now I can use that equation that I created to kind of answer some of these questions below here. If Erica travels at that same rate, how far will she go in 3 hours? Well, when they give us 3, is 3 a d value or is 3 a t value? 3 is not a distance, it is a time, so 3 is a t value. And that makes sense because they're asking us about the distance. They're asking us how far. That's a distance. So t, I'm going to plug in 3 for t. So d is equal to 60 times 3. So distance is equal to 180 miles in 3 hours. And last but not least, this time, they're asking us how much time. So this situation, they're asking me to find t. How much time will it take for Erica to travel 150 miles? So 150 miles is the distance this time. So 150 is equal to 60 times whatever the time is. And now we have a baby equation that we can solve. The 60 is preventing the t from being by itself, so I will divide both sides by 60 to get t is equal to 150 divided by 60 is 2.5. So it will take 2.5 hours. That's another thing I want to say. 2.5 does not turn into 2 hours and 50 minutes. It's 2.5 hours, which technically would be 30 minutes. 2.5 hours or 2 hours and 30 minutes. All right, and there is our first example. Nothing crazy. That's definitely something I've given you in the past in 7th grade.